Okay, this is text classification part 2. We have covered the first one, which is the unsupervised. We covered the spatial and hierarchical agglomerative clustering and also the naive text classification. So that one is based on distance method. We use the cosine function in order to determine the grouping of the document based on the seed of the cluster. So today we will cover the supervised learning, in which it requires label for us to build a model. So usually we will have two dataset. The first one is called training dataset, and the second one is called testing dataset. So the reason why they divide into two is that the training dataset is used to build the model, or we use the algorithm to model the data using the method that given. For this classification, we have a few methods. Okay. So the most important part is we know which part of the features or column is called label of the document. So the task is to find a model for the label of the document. We need to find a model means we train the model. Okay, so it could be any algorithm or methods, but the main objective is to train the model for us to be able to.
Prof, sorry Prof.
Yes.
Prof punya slide bergerak kah?
Masih introduction.
Oh, oke, sorry.
Nampak?
Kami punya view sekarang nih dalam edit mode, bukan yang presented punya mode.
Oh, ya. Oke, kejap. Mungkin I need to escape first. Discard. Better share screen kan. Oke, nampak dalam presentation mode.
Belum Prof, masih macam tadi.
Ataupun dia on the way. Oke, wait.
Oke, ada.
Hah?
Oke, saya ada.
Alah, saya kasih stop balik. Kejap, saya share balik. Oke, sudah.
Oke, saya Prof.
Okay. So as I mentioned just now, for classification, we need two data set. The first one is used for training, and the second one is used to evaluate the model that you have trained. But the most important part is we need to know what is the features or the column that represent the label of the document. So the task is to train a model. It could be any algorithm, for example, support vector machine, naive Bayes, decision tree, and many more. The task is to build a model or train the model in order for us to give a label to the new unseen data. So given a new unseen document, based on the content of the document, we would be able to predict the type of content that we have for that particular document, so that when we given any unseen document, we will have high accuracy in classifying them. So we have the training data set, we have the test data set to evaluate the performance of the model. So if you look at the diagram here, we have the label document for training set and also the test set. So normally in the experimental setup, we have 90% from the document is used for modeling, 10% is used for testing. Or you could have 80% and 20%, 70% and 30%. So depending on the characteristic of your document, so each of these partition of training and testing will give you different results. So you need to look at all these 3 or 4 options, for example, 60 and 40. Okay. So once we train the model, so this is the learning algorithm. So this one could be support vector machine, decision tree, or naive Bayes. So once we build the model, so we have the model here. So we take the label document to be classified, and then we compare the actual class with the predicted class. So from there we can compute the number, the percentage of correctly classified document. So to formalize the setting for the supervised algorithm, so for the training data set, we should have a subset of that document from the full document. So this is used for training. So our task is to build the set function that will map your document to a class, where this class is belong to this class should have full set of classes that we have. So we will map the document to the class. If they are belong to the class, then we say the value is 1, otherwise 0. Okay. So when we have pair of document J and P class, where DJ belong to the set of the training set of document and CP belong to the full set of the class. So we want to know whether this is 1 or 0. 1 if that document belong to class P, otherwise not belong to class P. So this is the training set function that we want to find out. How do we optimize this so that we can increase the classification of the document? So we need to fine tune them. So in the training phase of classifier, normally we determine the number of classes that we have. Contohnya, we have 3 classes. So we scale sport or political, or this one is financial. So we have 3 type of classes. So given the document, we as the expertise will divide them into the classes that we define here, and then we say, okay, we have all the label already, and we feed them into the classifier for the training. Okay. So to evaluate the classifier, we use the test set, subset of document with no intersection with the training. So that means if you have a full set of data set, you will divide them into training and testing. Okay. So evaluate is done in a 2-step. The first one, we use the classifier to assign classes. So you will have the predicted classes versus the actual classes. So we we compare how many percentage that they are correctly classified. Okay. So for example, like here, you have the document in test set, and then you convert them into document term matrix, and then you select a few of the features only, meaning that you could have a threshold TF IDF. For example, you only take all the features or wood that has TF IDF above 3. So you want to have you want to reduce the number of features in your text document matrix, and then you feed them into the classifier. Then this is the predicted classes, and this is the actual classes. So you want to compare these two. So how many percentage that correctly classified? Okay. So that is the run through of the actual classification process. So once the classifier has been trained and validated, so it can be used to classify new and unseen document. If the classifier is well tuned, then you will have classification is highly effective. So today we will cover this two. This is decision tree classifier and also the K nearest neighbor. This is one or two of the most common algorithm used for text classification. Okay. The reason why these are chosen in this course is that because we have learned about entropy, and also we have learned about the cosine function. So the entropy is used by this algorithm, and cosine function is used by the KNN classifier. Okay, for the decision tree, the training set is used to build the classification rules. So like, for example, for decision tree, they have in the form of this, the tree. So this is, so what happens is that when you are here at the root of the tree, so you want to check, okay, they belong to, okay, this is keyword A, this is B. And then if the document has keyword A, then you go here. And then if C, you go here, D, you go here, over here, maybe E, F, G. Okay. So at the end here is the class label that we have. This is your class label. So for class label 1, you should have A plus B, A plus C, which you should contain, you should have a document consisting A and C. For class 2, you should have a document containing A and D. Okay, so that's the idea here. Okay, so if we use a normal relational table, so this is a way of classifying tabulated table. So if you have this is as your training data set, and this is your label. Okay, so if you have a new data here, so what will be the value for the play? Are we going to play or no? So what happens is that we will build a tree based on this data that we have. So the tree looks like this. Okay, so if today is rainy and windy, so that means we don't play. So if we look at the end here, the leaf, the value of the leaf here is the class label. And what you have here is the attribute. Okay. and these are the value for your attribute. Okay, and the question here is that when we have this decision tree, how did we choose the attribute to be at the root? This is your root. Okay, why not humidity is up here? Why not windy is not here? So the way we choose what to be here is that we want to use the entropy value. So the entropy value saying that if the value of your entropy is 0, that means pure. So that means you will choose the one that will split your table into more, split your data in such a way that all your data that follow this path will have the same class label here. You want to maximize the percentage of the data that has the same label here. Okay. So for example, like this can also be the rule saying that, okay, if sunny and high, then play no, because we have sunny and high here. So if sunny go here and then high, then the class is no. So just simply applying this model. So what we want to study is how did we construct this? How do we be able to construct this table? Okay. So when we apply the decision tree for the text, we look at the keyword. So over here, we look at the attribute values. For the tree, for the text, we actually look at the text that we have. Okay. So this is the process that we are looking into because we want to know which keyword we use in order to split them. So the goal is to build decision tree for attribute play. So this is your label. So select one of the attribute other than play as root, and then we use the attribute values to split the label, the subset. So this is your root, and then you choose the attribute what you need to put here, and then it depends on how many unique value you have in the attribute, and then you will keep repeating. Okay. So for example, like this, step by step. So for first we look at the outlook, and over here we have the record ID. So from here we can compute the entropy because we have label. So for example, this one 4, 6, and 10 in our data set we have no, yes, yes, and 10. So that means we have two here. So that means we have two no here and two yes. Okay. So we pick the attribute that has the unique value that can split your data in such a way that all of the member here belong to the same label. Okay, so but this one is just an illustration where we keep splitting them. So once we go for the first attribute, this is the second attribute, and then third attribute, and finally we have this. So when do we decide to stop? Is when all the member that you see here has the same label. Okay, and also maybe you can set, okay, I just want to have two depth level. So that means we have two level of layer. So we do not want to have unbalanced tree because it will affect our computing cost because over here we are comparing 4 times. Okay, so we want to have a balanced tree. Okay, so Again, the splitting process strongly affected by order of split attribute. So depending on what attribute you have, so we need to have balance or near balance tree because we want to reduce the cost of computation. So rule of thumb is we select attribute that reduce average path length. So there are two considerations here. The first one is to, for example, if we start with 1 and then divide by 3, so we will start splitting them level by level. We don't go by depth like this and then split and then split. So we want to have a balanced tree. We want to do it level by level. Okay. So for the document classification, the way we consider splitting the tree is that we have internal node associated with an item. So index term, which means the word or the keyword that we use. With each leaf, associate a document class. So that means your leaf will be your class label. So this is your class label. Okay. So this is your leaf. Okay. So with the edges associated binary predicate that indicate the present and absent of the index term. So this could be A, B, C, D, E, F. So if you have B and F, you go here. So how do we formalize the concept of classification for document? We will have a set of nodes, which is the V. So we have this tree. So this is your V. This is your root. And the edges would connect the V and V or the root to. So this is your edges. And this one is your class. Okay. So this is your class. So the tree can be defined using the vertex, the edge, and the root. And this is a cyclic graph, means there is no circle here. So the edges is determined by connecting two vertex. So if we have edges V1 to Vj, so V1 is the father, so this is your father, and this is the child node. Okay. So everything here is called the internal nodes, and the last one is the leaf node, which is the class. So this is the definition of the tree. So this is the basic one. So for example, we come to the root. If your document has chemical, you go here. If your document has chemistry, you go here. And then this is your class. Okay. So when we want to do the classification of the document, we need to define some of the term. For instance, we need to define the set of index term of a document collection. So this become your keyword that you want to use to split your document. And you also have predefined classes, and also you have some predicate set of logical predicate of the index term. This is we want to use to find the direction for a new document. Where should they go based on the keyword that they have. So the decision tree that we have will have 6 tuple. So of course you have the vertex, you have the edges, you have the root, you have the function, and this is the keyword that we use to move in the tree, and also we have the the class, and also we have the function that associate with each edge of the three logical predicate of P. So this one is, we want to show where should the document go, left or right, depending on what value they have for the index term that we have. So to illustrate this one, we first associate all document with the root. So we're starting from the root. So the second step is to select index term that provide a good separation of the document. And then the third one, we will repeat until the tree is complete. Complete means you have all the document in a group, and all of them have the same label, or you have reached the threshold of 3 depth of your decision tree. Okay. So for example, for this one, if we have keyword A, B, C, H, so we will start from the root, and each of the grouping here depends on the keyword that we have. So A, B, C, H, and then we will further divide them into D, E, G, and then and F, and then we have this. Okay, so that means this is we have class D, class B, C, E, A, and F. So consisting of the document. So we use keyword in order to split the tree. But the choice of word that we use will be evaluated so that when we use the keyword, it will maximize the value of the purity. So the lower is the value of the entropy, the better is the grouping that we have. Okay. So we use the information gain or the entropy to select which term we use to split your document, and then the selection of the term with high information gain tend to increase number of branches at a given level and reduce number of document in each resultant subset. So for example, you start from the root here, so every time you split your document, so you will have reduced number of document here, and then you split again, so you will have reduced. Okay. So I recall again the formula that we use for entropy. So the entropy is highly dependent on the probability of the document class in your grouping or the cluster that we have. So basically this one measure the homogeneity of a node. So how pure is the node in terms of the class level. If all the member of the group belong to the same class, so that means that the entropy value is 0, so high purity. So that is the objective. We want to maximize the purity of the grouping having one label only. So that's why we need to choose the right keyword. So for example, like this, if the splitting of your document consists of these three. So for the first grouping, we have 6 documents belong to class 2 and 0 belong to class 1. So for this one, the entropy value is 0 because we have much pure content of your grouping here. So basically the probability of having class is 0, the probability of having class 2 is 1. So when you plug in the value here, 0 times log base 2, 0 plus 1 log base 2, 1, we get 0. Okay. As the number of class 1 increase and class 2 decrease, so we recompute and we get 0.65. And then 2, 4, we get 0.92. So if you compute 3 and 3, the value of the entropy is 1. Okay, so we don't want to have this because this is 50-50 belong to class 1 and 2. We want to have this, which lower the value of the entropy. So the information gain is computed by computing the entropy before and after. So we take the differences. So we compute the entropy of the whole set of document, but this one, when we split them into few group and then we take the weightage in order to compute the total entropy of your subset. So how it looks like when we split them, for example, like this, we have 18 document, 15 belong to class 1, 3 belong to class 2. So this is before. So when we use the keyword A, B, C, then we split them into 3. So we can compute the individual entropy here. Okay, and then we sum up all of them, but we need to have the weightage here. So the weightage here is 6/18. This is 6/18 as well, 6/18. So when we compute the information gain, so the initial entropy, we take all of this. So we have 1518 and 1518 plus 318 and 318. When we compute, we get 0.65. So this is the initial entropy. So once we split them, so we already pre-computed them in the previous example. So we add up all of them, but we need to use the weightage. Okay, 6/18, 6/18. We add up all this value, we get 0.53. So that means before the splitting, our level of purity is 0.65. And then after the splitting, our level of purity is 0.53, which is lower than this. So this is how much information that we have gained by splitting them into three set of grouping. So it all depends on the keyword that we have chosen here. Okay, so if we chose XYZ or CDF, so for example like this, they will give us different distribution of the membership here. So the entropy for this is 0.92. This is 0, 0 because we have all belong to class 2. So when we compute the initial entropy, it is 0.65. Okay, after we split them, so this is 9/18 because we have 9 here. This is 5, this is 4. So this is the entropy. This is 5 and 4. So we get this. So it means that by using CDF, we have better splitting, better model because the IG is higher. Okay. So what we want to do is we want to reduce the value for this because this is always the same, but we want to reduce this by selecting the right keyword. Okay. Any question? So you will do this one later on. Okay, let me finish with this one. Okay, the problem that we have is that sometimes given a new document, since we already build the tree, and then if we have a new document, but that document do not have the keyword that we used to construct the tree. So in that case, we cannot classify that new document. So what happened is that one of the solution is to delay the construction of the tree until new document is presented for classification. Or what you can do is you build tree based on features presented in this document, avoiding the problem. So at least the document that we want to classify has at least all the keyword that require them to reach the leaf of the tree. So that's the only problem that we have. Okay. Any question?
No, Doctor.
Okay. So the second classifier is called K nearest neighbor. So K refer to number of neighbor that we want to compare. So what happened is that if we have new document here, let me give you here. Okay. So if we have new document here, so in this case, in the circle, this is 4K, 4 and N, 4 nearest neighbor. So since the three document belong to class B, so this one will be assigned to class B. So it depends lah. So you can have 8 and N or 1 and N. Okay, so you can try all of this, but for 4 and N, the new document belong to class B. So the K nearest neighbor, sometimes called lazy classifier, because we do not have to run the modeling. We don't have to train the model because the way they classify is based on computing the distance only, the nearest neighbor around the new document. Okay, so how do I pick the four nearest neighbor is by computing the distance. So this is very easy because we just use the cosine function in order to determine the distance. Okay. So for the K and N, to each document pair, we assign a score. So this score is actually the distance between the new document to the class that we have defined here. Okay. So for example, okay, this is okay. The score here is computed by looking at the similarity between the new document and the document that you have. And this one depends on the whether we look at the nearest K. Okay, so we look at the nearest K here to the new document, and we add up we assign the label to that particular document depending on which one is the majority. Okay, so for example, like this. Okay, so we have new document, and the table here showing the distance between document 1 to document 91, 62, 41, and 13. Okay. So if I use one nearest neighbor, that means I will pick the one document only. So your label will be A. If I pick two nearest neighbor, so the two nearest one will be this. So we can have the default value where whenever you have A and B, you pick the shortest one here. So if you pick 3 and N, then you will have majority B. If you pick 4, then you have A and B the same. So you can get the nearest one here. And then C here, okay, this is for the 5 and N, still you get A. And then if we have, let me erase this. If we have 6, So that means the majority is A. Okay. So for KNN, when we give a new document, we compute the distance, we sort them, and then it depends on what is the value of K. Then we take the majority label of the nearest neighbor of the new document that we have. Okay. The problem with the KNN is that if you have 1 million or 10 million data in your data set, that means you need to compute 1 million or 10 million times because you want to find the distance between the new document and the document that you have in your database. Okay, and that is high competition. And at the same time, also we want to determine what is the best value of K. 1 NN or 2 NN. So we need to try at least up to 6 NN. Okay, that's it. For this one, I will skip this one because this one I have moved to the data mining already, on the machine learning already. So I will not cover this one. Okay, any question? Any question?
Everything is clear, Prof.
Okay, so I'll give you 15 minutes or 20 minutes to do this small exercise just to have a clear understanding on how do we compute the IG here. So this is your IG, and this is the entropy before, and this is after. So over here we have 20 document, 10 and 10. Okay, so I give you 15 minutes or 20 minutes to do this one. Then we solve the problem together. Okay.
Prof, the formula, the slide sudah upload ke, Prof? Mau tengok formula.
I think so. Let me check.
Belum upload, Prof.
Tidak kan? Okay. I upload now. Ya, belum lagi. Okay, so I give you 10 minutes. Nah, oh, what happened? Okay, the time now is 10:30. I get back to you 10:50 lah. Okay. So in the exam, you should have around 20 to 25 minutes to solve this. Okay. Oke. Saya dapat jawaban. Boleh kita discuss.
Ya, Prof. Ada di chat.
Oh, di chat. Semua dapat nih kan? So the initial entropy is 1 kan, because we have 10. Lepas itu selepas splitting berapa? Selepas splitting we have 1 0 and the other one is so what is the entropy for the, if we use x, what is the entropy? If we use x,
X 0.41.
siapa? So 3/9 log 3/9 plus 6/9 log 6. No, for the 6/9, so that means this is 9/20. Berapa kamu dapat? For the x, if we split into x only, what you get?
0.41 kah? Saya dapat 0.41. Kejap ha.
0.918.
Kalau pakai x,
Ya, Prof.
Salah tengok. 0.92. Ya, ngam. Salah tengok pula saya. Entropy.
entropy untuk x.
Untuk X 0.92 total.
0.92 kejap ah. Yang for y, what is y?
For Y, 0.721.
Kejap ah. Campur. So, yang pemberat itu sudah masuk lah kan? Yang for the Y berapa tadi itu? For the Y.
Saya dapat 0.72 lah, Prof.
Coba tunjuk kamu punya anu tuh. So let me write here. So for this one, for the X, for the X, ini termasuk pemberat jalan nih kan, 9/20. Now this one is 3/9 log 2, 3/9 plus. So you're familiar like this lah. Betul. Kan?
Bukan 9/20 itu untuk kira infogen jak kah, dokter?
No, yang ini pemberat untuk ini saja lah. Ya betul lah, yang ini untuk pemberat dia boleh juga. Tapi I want to know.
Oh, boleh kira sekali.
Yeah, this is the entropy untuk yang ini based on kalau kita mau tengok the gain lah. So 1 minus yang ini dan minus ini. Yang ini berapa kamu dapat? For this one. Point 41 kan?
Iya, Prof. Maksudnya, Prof, yang entropi yang untuk X tuh kita ambil pemberat yang 9/20 juga.
Iya.
Isi.
Kan? Point 41. Tapi
Iya.
you mention tadi betul lah kan? Point 41. Tapi yang tuh without.
Itu untuk information gain, dokter, yang 0.41 tuh kami dapat.
Oh, oke. So kita tinggal
Tapi
dulu.
ya, tapi yang untuk X yang Prof kira itu pun sama juga macam yang dalam pengiraan info gain itu, yang komponen untuk X.
Oke. So yang ini 5/20, 1/5 log 2, 1/5 campur 4/5 log 2, 4/5. Ini berapa?
Ini 0.18.
Oh, dan bila kita add up tuh lebih kurang lah kan?
Iya, sebab nanti dia ada 1 minus juga tuh.
Ya. Ini 0.18. So Z is 0, so we abaikan lah. So dia punya IG is 1 minus 0.41 minus, kita total terus lah. So 1/8 is 59, so equivalent to 0.4. Oke lah. So semua dapat the right figure here lah, 0.41 kan. Tapi kalau yang ini I shorten the calculation, tapi kalau dalam soalan itu dia bilang kirakan entropi untuk ini, so tidak perlu tuh pemberat lah. Because yang pemberat ini only we want to use for the IG. Tapi kalau dalam research kan is more on we need to use the weightage juga lah, because there how many of the data distribution tuh yang contribute to the entropy of 0.41. So that's why we need the pemberat tuh. Tapi just to look at one case, like one grouping, what is the entropy, without thinking of what is the portion of that small group from the big group lah. So okay, so that's good.
Prof, ini soalan
Yes.
begini kan keluar exam kah?
Keluar.
Jadi kalau dia kena tanya entropi itu, kita tiap payah letak lah kan yang 9/20 itu contoh dia.
Iya, tidak payah letak nih.
Oke, kalau entropi.
Tapi when you study this algorithm macam KNN ataupun when we use decision tree, so always remember that entropy ini dia boleh kena pakai dalam decision tree, especially in decision tree lah, because they want to split the data into a situation where all them in one group they have almost same classes. So we use entropy. When dealing with the label, we use the entropy. But when we use clustering ataupun distance base ataupun KNN, all of them using the cosine lah. So that is the theory behind that one. Some other classification like naive Bayes, they use the probability, and the rest macam support vector machine is using distance as well, distance to the hyperplane that separate the classes. So that is support vector machine. Deep learning, they use the weightage of the neuron in order to map the input to the output. So banyak lagi classification yang lain tuh, those yang already taken, like Abdul Hanan already take the ni kan, the machine learning kah? And also Zul sudah ambil kah tuh? And Raja, yeah.
Yang subjek machine learning kami sedang
nih, dokter.
ya sedang ambil kami.
Oh, machine learning. So good lah, because you have the knowledge lah. Machine learning. And next semester kamu ambil apa?
Itu tidak pasti pula, Prof.
Belum tengok lagi, Prof.
Siapa? Saya pun curious. Baik. Oh, iya kan. So kamu ambil machine learning, and next semester kamu ambil advanced data mining. So more or less the same lah. So in machine learning apa kamu belajar? Contohnya lah.
Kami belajar yang gini juga, yang decision tree.
Okay.
Lebih kurang juga, dokter.
belajar entropi semua lah, Gini index semua.
Iya, ada juga entropi.
Tapi
Gini?
kami apply terus, Prof. Apply di WK.
Oh, so bukan
Yang pengiraan, ya. Pengiraan tidak.
Ya, kami belajar classify aja sih ya, dokter.
yang behind the scene tidak lah. Behind the scene means what happened actually. So you know how the tree is being constructed. Because yang to split the tree you can use the Gini index juga, and also entropy juga. So yang clustering nggak mau belajar apa? Mau on applying kah?
Clustering macam tiada. Kami fokus classification dengan regression, dengan neural network.
Oh, so for regression tuh you know how to regression you belajar single simple linear regression and multi regression lah kan.
Ya, Prof. Ya.
And for clustering tiada. And association rules, market basket analysis.
Itu macam belum.
Oh, okay lah. Okay, so I'll be seeing you next semester. So I think for this course, that's all for the information retrieval. But kita punya exam in January kan?
Iya, Prof. Prof, ada contoh soalan exam kah?
Ada. Nanti saya share lah.
Oke, thank you, dokter.
Okay, so nanti ada juga assignment for you to prepare for your final exam lah. So you have maybe 3 to 4 weeks lah to look at the assignment. So mungkin the persoalan tuh hampir sama, tapi to test your knowledge how to use the formula lah. Okay, so next week I will put up your standing grade. Cuma ada yang miss quiz kan, miss quiz. Nanti I give you quiz, I will drop the lowest one lah. Okay. Anything else? Ada soalan? So,
Prof, yang assessment untuk di subjek ini tinggal satu lagi kah? Assignment number 3 kah?
ada dua atau 3 quiz, tapi dia based on the previous 3 chapter itulah, and also ada dua assignment lagi. I wanted to give the assignment because to give you a glimpse of what the final looks like. Sebab for me 3 hours if you tidak cekap dengan calculation tuh mungkin tidak cukup masa. So at least with the assignment you know what to expect in the final exam. Okay? In most cases, for Plum student jangan tidak sempat jawab semua sebab maybe kurang exposure to the question yang will be given in the final. Itu yang komen saya dapat dari previous student, dia bilang tidak cukup exposure. So dalam lecture, dalam contoh-contoh boleh paham, tapi kalau dibagi soalan yang kena twist sedikit, terus tidak boleh jawab. Macam itulah. So that's why the assignment itu is for you to look at the question and understand the question, and how do you apply the knowledge yang you sudah belajar itulah. So kira revision 1 kali lah. So harap-harap your standing grade tuh is A, because the final exam tuh memang susah kalau you tidak prepare lah. Dari A boleh pergi C. Tapi harap-harap semua above B lah kan. Okay. So next week I will share your standing. So get yourself prepared for your final by looking at the question of the assignment and buat sendiri dulu. Jangan dulu tanya kawan-kawan, buat sendiri and baru compare dengan kawan. Okay. So if we don't have anything, see you again next semester and happy holidays. And thank you for your patience for this class. I know 7 weeks, too many things happen, and we all pun trying to finish the semester without any complication or delay. Okay, so with that, thank you again and see you next semester. Okay?
Thank you,
Alright.
Doctor. Merry
Thank you,
Christmas
Prof.
and Happy New Year.
Happy holiday,
Okay.
Prof.
Happy holidays.
Thank you,
Bye.
Prof.
Yeah.
Bye.
Okay. Anything you WhatsApp me lah. Huh? Okay. Bye.